kinetic and potential energy. Who can remind us? Raise your hands. Who can remind us what we said about kinetic and potential energy? Okay, choose one. Abdullah Abdulaziz. Abdullah Abdulaziz. You can unmute yourself. Yes, Abdullah, can you remind us, please, what we talked about kinetic and potential?
Kinetic is an energy that comes with work,
With work,
with moving.
with motion, yes. Any object that is in motion has kinetic energy. Has what? Kinetic energy. Yes. What about potential?
Potential is the stored energy.
Stored energy. Yes. And the object gain potential energy because of what?
Kinetic.
Because of what? Okay, Abdullah, we'll come back to you. Another one. Another one. Abdullah Batawil. Batawil.
نعم.
What is potential energy?
uh, energy that is
Mm, Potential energy. Okay, welcome back. Listen to your friends. Abdul Rahman Sultan. Abdul Rahman Sultan. Abdul Rahman Sultan. You can unmute yourself, Abdul Rahman.
Assalamu alaikum.
Assalam.
I answer.
Yes.
Potential energy is the stored energy.
Yes, and the object gain is gain potential energy when يعني if you are now if you put any object on ground, it has potential energy.
Repeat the question, teacher.
If you have an object on the ground, okay,
Yes.
it has a potential energy.
Yes.
How? يعني
Because
like this ball. يعني this ball, if the ball on the ground touch the ground, it has potential energy.
yes,
No.
because it has stored energy.
No. The ball, we said, has two kind of energy when it is in the air. Okay, when this ball in the air, it has two kind of energy. So it must be in the air like this one. Okay, there's a distance between it and the ground. Okay, so
Yes.
this distance, or now it has height, so it has potential energy. Potential energy, because we raised the ball over the ground, so we have gravitational potential energy, gravitational of gravity, right? We said it is called this attraction. This attraction between the ball and the earth. It is called, this attraction is called what? Gravitational potential energy, right? So potential energy, an object gain potential energy when there is a distance between the two objects, like the ball and the ground. There must be a distance. There must be a distance. Okay. And for kinetic energy, the object must be in motion, must be in motion.
Motion.
Okay, so kinetic energy, the object is moving. So if the ball is on the ground and not moving, so no kinetic energy, no potential energy. Okay?
Okay.
Okay. So we can watch this video just to remind you about difference between potential and kinetic energy.
Imagine you have a ball which you throw upwards. As the ball travels upwards, we say that it has kinetic energy. Kinetic energy is a form of energy possessed by a body due to its motion. Therefore, anything that moves has kinetic energy, such as a car traveling on the road and a plane flying in the sky. Even you possess kinetic energy when you walk or run. In fact, the faster a body moves, the greater its kinetic energy. Therefore, when you run, you have more kinetic energy than when you walk. When a body stops, there is no more kinetic energy. When you come to a stop, or when the car stops moving, kinetic energy becomes zero. If we now raise the ball to a certain height and release it, what happens? It starts falling downwards, right? It starts from a position of rest and then gains speed when you let it go. In other words, it starts with zero kinetic energy and then gains some kinetic energy. Where does this kinetic energy come from? This energy, which is stored in the ball, is called potential energy. Potential energy is a form of energy stored in a body due to its position. Let's have a closer look. Here, the position is the ball's height from the ground. When you release it, the potential energy converts to kinetic energy. In fact, the higher the ball, the larger its potential energy. That is why if we raise the ball to a greater distance from the ground and release it, it will hit the ground harder. Let's look at another example. Look at the slingshot. It has stored energy with which it can throw the bird up to a certain distance. Based on its position in the slingshot, we can say the bird has potential energy. As soon as it's released from the slingshot, it gains kinetic energy. And because of kinetic energy, it is able to apply force on the little houses to break them down. Time for an exercise. Who has the greatest potential energy? Bubbles has the most potential energy because she is at the top. We know that potential energy increases with the increase in the distance of a body from the ground. Let's summarize. Potential energy is the energy of a body due to its position. Kinetic energy, on the other hand, is the energy of a body due to its motion. Potential energy mostly depends on the distance of a body from the ground. Kinetic energy depends on its speed.
Okay, guys, as you saw here in this video, for the potential energy, okay, the energy due to position, okay, so when the object is up the ground, okay, like this ball, okay, if there's the ground down it, okay, so this must be a distance between the ball and the ground. There must be a distance between the ball and the ground, okay, or a height. So mostly depends on distance from the ground. An object, if the object touches the ground, okay, if the object touches the ground, so no potential energy, okay. And if we draw another ball here, so this ball, the third one, the last one here, it has more potential energy. If we draw another one up, so it has more potential energy because it has more height, okay, but it's higher than the other balls. Okay, so potential energy, we must have a distance between the two objects, or especially if we are talking about an object and the ground, it must be a height. Come to kinetic energy. It's energy due to motion. Due to what? Motion. Okay, so it's energy due to motion. So it must be the object is moving. If the object, like this ball, it is on the ground, is not moving and on the ground, so no kinetic energy, okay. And depends on speed. Depends on what? On speed. So if the object, if we have two objects and one of them is moving faster, it means it has more kinetic energy. So this is what we talked yesterday. And the last point is that we said mechanical energy. Who can remind us of mechanical energy? Mechanical energy, we said mechanical energy equals what? Yes, yeah, Mazen. Mechanical energy
Mechanical energy is the sum of potential energy and kinetic energy.
Excellent. So it is the sum of, so we have here this potential energy and this is kinetic energy. If we add them together, so we have what? Mechanical energy. So mechanical energy equals potential energy plus kinetic energy. Okay? Hope you understand this point. Okay, so now mechanical energy equal potential energy plus kinetic energy. And pay attention here, we are talking about the object itself. We are talking about the pole, right? We are talking about pole, so we are talking about object. We are talking about pole or the object. Okay, we are talking about the object. Okay, for the potential energy and kinetic energy for this pole. So we are talking about the object. What about the particles inside the object? The particles inside the object. Do they have potential and kinetic energy also? Who can answer this question? Do particles have potential and kinetic energy? Do particles have potential and kinetic energy? Who can answer this question? We know that matter is made of particles, right? Okay, who can answer? I choose Abdulrahman Sultan. Abdulrahman Sultan. Abdulrahman Sultan. Abdulrahman. Okay. Mazen. Where is Mazen? Okay, Faisal Yusuf. Faisal.
Yes.
Do particles have potential and kinetic energy? Particles inside matter.
Yes.
Yes, okay. Have both or one, only one of them?
Both.
Both. Excellent, James. Excellent. Thank you. So if we go now back to our book, we'll find that the next page is talking about thermal energy. It's talking about what? Thermal energy. And this thermal energy is related to kinetic and potential energy, but not for the object, only for the particles. For what? For particles. So here we are going to talk about the particles of the object. We can draw, for example, a box here, okay? And we can put small particles inside. If we put more particles inside, okay, like this one. This matter could be solid or liquid or gas. The particles are near, very close to each other. Okay, so these particles represent solid or liquid or gas, Hussam Mustafa.
Yes, yes, mister.
This shape or particles represent solid or liquid or gas.
Gas.
The particles are very near to each other.
Solid.
So, okay, look to this other one. If the particles taking this shape, don't say when I finish the whole one. Okay, if we have a third one here, like this one, and the particles inside are like this one. So which one of them, which one is solid, which one is gas, which one is liquid?
The first one is solid, the
First
second
one
is liquid.
Solid, the second one is liquid, the third one
And
is...
the third gas.
The third is what? Is gas. So the first one, excellent. The first one is what? Solid. We can put S as it is solid. Here we can put L as it is liquid. Here we put G as it is what? Gas. Okay. So change color. So here between particles we can find, yeah, there is no spaces between particles. The particles are all almost are attached together closely. Okay, so it has very small spaces. So we can say as we have spaces, so we have potential energy for here for these particles. Also here we have distance between particles. We have distance between the particles in liquids. So we have more potential energy. So the potential energy here is greater than the solid. If we go to gas, the distance increases. So it means we have more potential energy. Okay. So we are talking about distance between the particles inside matter. Okay. Sorry for this. What about the movement of particles? Who can remind us about the movement of the particles? Movement of particles. Who can remind us of movement of particles between gases, liquids? I will say Mazen.
Yes.
Yes.
The
Can you remind
particles.
us?
Yes, the particles. The solid can't move because they are attached to each other.
There is a kind of movement. They cannot change place. They cannot pay attention. There is many kinds of movement. One of the, or motion. In motion, when an object or the particle can change place. In solid, the object change place.
Uh,
The particles inside the
no,
object, it changes places.
no,
No, excellent. But they can what? They vibrate. They what?
vibrate.
Vibrate in their places. Okay. What about the liquid?
They can move, but
Ah,
they can move, but in small area.
yes, they can move or slide over each other. So here we have a motion. So in solid, we have low kinetic energy also. Okay. In liquids, we have more kinetic energy because it is more free to move. So the kinetic energy here is greater than the kinetic energy on solid. Okay. For gases, what do you
They have
think
the
about?
greatest kinetic energy.
They are moving very fast, so they have the greatest kinetic energy. Okay. So here in gas, we have both potential energy and kinetic energy between particles, also in liquids, also in solids. Okay. So, as we said before, potential energy and kinetic energy, when we sum them together for an object, pay attention, for the object like a ball, they give us what? Mechanical energy. They give us mechanical energy. But here, if we add them about particles, they will give us, who can deduce what they give us if we are talking about potential energy and kinetic energy of particles. What will be the result? Potential energy plus kinetic energy for particles equal, try to think. We said potential energy and the kinetic energy for an object give us the mechanical energy. What if we said potential energy and the kinetic energy for particles? The result will be what? What energy? It's very easy. Raise your hands. Who knows the answer? Raise your hand. Abdul Rahman Khalil. Abdul Rahman Khalil.
Yes.
Yes,
What is
Abdul
the
Rahman. Answer the question, Abdul Rahman.
what is the question?
Yeah, I said the question many times. Where have you been?
I didn't hear very well.
Okay. Again, potential energy and the kinetic energy, the sum of them for particles. What will be the result? We said
Thermal
for
energy.
thermal energy. Thermal energy. Okay, so because we are talking about what particles? We are talking about particles. So potential energy and the kinetic energy for particles, if we add them, what is the result? The result will be
Thermal energy.
thermal energy. If we are talking about an object, the result will be mechanical energy. Mechanical energy. Okay, thanks, Abdurrahman. So now, guys, let us watch another video. The small one, just to clean the screen.
They have kinetic energy. The particles in matter are moving at different speeds in all directions. Because these particles are in motion, they have kinetic energy. These particles also can collide, and kinetic energy can be transferred from one particle to another particle.
The words temperature and heat are often used to mean the same thing. Actually, they are related, but they don't mean the same thing. Temperature is used to measure how hot or cold an object is. Objects with the same temperature can give off different amounts of heat. Think about this situation. Here are 3 beakers with different amounts of water in each. The temperature is exactly the same in each beaker. The question for you is, which beaker contains the greatest amount of heat energy? Well, the largest beaker contains the greatest amount of heat energy. Imagine if the temperature had been much higher, such as boiling. If the water were to spill on you, the large beaker would hurt the worst because it has a greater mass of water. Therefore, even though the temperature is the same in all 3 beakers, the larger one has more heat. Heat is determined by the temperature and the amount of the substance. Temperature is measured with a thermometer, which is usually a hollow tube with either mercury or colored alcohol in it. The fluid will move up or down the tube, depending upon the temperature of the substance being measured. It works like this. All matter is made up of atoms and molecules that are in constant motion. We can't see this motion because the atoms and molecules are so very small. A piece of paper is 1 million atoms thick. When matter is heated, the atoms or molecules move faster with greater strength. They bounce around more and are more active. When the thermometer touches the object, the motion of the object's molecules is transferred to the molecules of the thermometer fluid. The fluid then either expands because the molecules are moving faster, or the fluid contracts because the molecules are moving slower than before. When the fluid expands, it moves up the thermometer and registers a high temperature. The motion of atoms and molecules in matter is called kinetic energy. So temperature measures the average kinetic energy of a substance.
Okay, guys, so it's talking about the same idea that when particles are in motion, they have kinetic energy inside the matter, okay, and this gives the matter its thermal energy with the potential energy. Okay, I want someone to read and to highlight just important points here. I want to read. I want to read. Raise your hands if you want to read. You can raise your hands if you want to read. Okay, we'll choose first one is Faisal. Yes, Faisal.
What
What is thermal energy? Every solid, liquid, and gas is made up of trillions of tiny particles that are constantly moving. Moving particles make up the book you read, the air you breathe, and the maple soup
Syrup.
you
Mm.
syrup you pour on your pancakes. For example, the particles that make up a book or any solid vibrate in place. The particles that make up the air around you or any gas are separate out and move freely and quickly because particles are in motion. They have kinetic energy like the soaring scorer
Soccer
ball,
ball. Soccer
soccer
ball. Yeah.
ball
Mm.
in figure 2. The
Mm.
faster particle move, the more kinetic energy they have.
Okay, in this part, you have to highlight only these points. Okay, thanks, Faisal. We'll take another one. Okay, Abdulrahman Sultan. Abdulrahman Sultan.
I read the second paragraph.
The second one, yes.
The particles that make up matter also have potential energy, like the interaction between a soccer ball and air. Particles that make up matter interact with and are attracted to one another. The particles that make up solids usually are held very close together by attractive forces. The particles that make up a liquid are slightly further apart than those that make up a solid, and the particles that make up a gas are much more spread out than those that make up either a solid or a liquid. The greater the average distance between particles, the greater the potential energy of the particles.
Yes. So here we know that particles have both kinetic energy and potential energy, and each paragraph is talking about solid, liquid, and gas for kinetic energy and solid, liquid, and gas for potential energy, making comparison between them. So the final paragraph is talking about the final result, what we get from all of this. Okay, I'll move down, just give me a second. Okay. Okay, another one to read the last one, the last paragraph. Faisal Yusuf, did you read before Yusuf? Faisal,
Yes, I read.
you read already. Okay. Okay, Abdullah Abdulaziz. مين اللي كان؟ Mazen, yes, Mazen. Mazen,
Yes, teacher, from when I
the last paragraph. Recall that.
recall that a flying soccer ball has mechanical energy, which is the sum of its potential energy and its kinetic energy. The particles that make up the soccer ball or any material have a similar kind of energy called thermal energy. Thermal energy is the sum of kinetic energy and potential energy of the particles that make up a material. Thermal energy describes the energy of the particles that make up a solid, a liquid, or a gas.
So pay attention here for everyone. As he said, thermal energy describes what? Energy of particles. Of what? Particles. But here, mechanical energy is what for the soccer ball, for the object itself. Okay, so when we are talking about the object, we are talking about mechanical energy. When we are talking about particles, we are talking about thermal energy. I hope this is clear for all of you. Now, if you open the site of your book, Magro Help, okay, you have a question, only one question in your weekly plan. It's homework, so you have to do it. I think I don't have to remind you that when you have a question in your weekly plan, so you have to do it by yourself. Okay, if you go to connected, have this version. Okay, you go here and you choose chapter 5, thermal energy. Okay, then lesson 1, thermal energy, temperature and heat. Okay, Ayman, I'll just finish this and answer your question. Okay, then you can see here these icons. You will move from this cursor, okay, until you get check. Okay, until you get check, you press check. It opens this one. Here in the middle, you have online quiz. Online quiz. Open it. Open the online quiz. Okay. Here we have some questions here. Okay, I want someone to answer this question. Okay, take 30 seconds to think about this question, everyone. Then come back with your answer. You have 30 seconds to think about this question. Okay, we have some guys want to answer. Okay, Ayman Ishaq. Yes, Ayman.
When we log into McGraw-Hill, we find a join class and we need to type in a code.
Yes. You can open your book, right?
My book is with me, yes.
No, the book on website.
But I can't open the ebook. No.
No, this one.
Where?
This interface, this user interface, you can see. You have this one?
Yes, you can see, but I can't open it. When I log in,
yes, it means that the sources are open. Okay, the sources are open. From here, I said from glossary you can open your ebook. From glossary you can open your ebook. If the other icon is not working, you can open it from the drop-down menu. Okay, and you can open from glossary. Okay. Okay, so back this question. You want to answer this question?
No.
Okay, try. Read the question. At least read the question. Okay, Abdullah Abdulaziz. Abdullah Abdulaziz. Yes, Abdullah.
Teacher, about the connected. I can open WinGo, but I can't open connected.
So your account must be activated from the school. Yeah.
So
because McGraw-Hill connected is different than WinGo. So you have to ask Mr. Khalid. He is the principal for the middle school. Okay, he will ask you some questions. Okay, if you, I think, there is some financial issue or something like this. I don't know the problem where. So because some students, their accounts are working, others are not. Okay, so you can know the reason why. Okay, from him. So anyone has any problem with McGraw-Hill, so you have to call Mr. Khalid. Okay, he's the principal of the middle school. He can tell you what is if you have a technical problem or other reasons. Okay, so now I want someone to answer this question. Okay, no more questions about McGraw-Hill. Okay, Mazen.
Teacher, how is mechanical energy different from thermal energy?
Yes.
I think the answer is mechanical energy is a property of whole object.
Yes.
And thermal energy is a property of the particles that make up an object.
Yes, excellent. You see here is mechanical energy. Okay. So we are talking about mechanical is a property of all objects. So we are talking about the object. So we are talking about mechanical energy. And thermal energy is a property of particles. Okay, this is the right one we are talking the whole period about. If you look to the first one, mechanical energy includes the kinetic and the potential energy. The thermal energy includes only kinetic. No, both of them have both. Mechanical and thermal have kinetic and potential. Okay, but here he is asking you about the difference, not the similarity. Okay, what is the difference between them? Both of them are similar in they are made of potential and kinetic, both of them. But the difference that mechanical is about the whole object, but thermal is about the particle itself. So now Shabab, now I remind you again the homework in your weekly plan, and you have to answer question 2 and 3 in this quiz. Here you open as I show you, and you have to answer question 2 and the question 3. Okay. If you don't have an account, it is not working. Okay, but the main homework is your weekly plan. Okay.